Hello everyone, welcome to my channel. Today I am going to describe vector, scalar quantity and first number, vector notation, graphical representation of vector, angle between two vectors, kinds of vector, what's different kinds of vector, first one, unit vector, zero vector, equal vectors, parallel vector, anti-parallel vector, negative vector, congruent vector, coplanar vector, orthogonal vector, and multiplication of a vector by scalar quantity. First we start vector. What is vector? In previous lecture we know a vector addition. In here, first of all, we know what is vector. Vector which have two things. First one, vector notation, which is represented by this. It's have two quantity. One its magnitude, and one its direction. A scalar quantity. A scalar quantity are those quantity which have only its magnitudes, not any direction. So we represent simply as a vector notation. See, vector notified as vector notation as a vector, which is written as a vector. Simply, it is notified by its magnitude. This is notation of magnitude, and this is notation of its direction. Graphical representation. Graphical representation of vector. What is graphical representation of this vector? Representation. First one, we know graphical representation. For clarifying the vector graphical representation, first we know if any vector notified by this diagram, then this point where from it originates is called its, which is called heads. It's called heads, and from where it originated it's called tail. So any vector, just imagine the vector A. So it is represented in any form, just like this, where it is where arrow moves, it is called its head parts, and where it's out from it originated is called its tail parts. That is what's graphical representation. And third one is angle between two vector. Angle between any two vector. Any two vector. So for finding the angle, first of all, just imagine two vector. This one this direction. Such one, just imagine this is this direction. And imagine this is 120 degree. So for finding the vector angle between two vectors, first this one is same. Suppose that it is in form of such like this, and angle between this vector is 120. So first, for finding the angle between any two vectors, first we find out whether its tail and tail parts match or not. If their tail and tail parts does not match, then its supported should be extended. Therefore we extend it in the same vector, because we know vectors can be go from one place to another without changing its magnitude and direction. So if we put it in this direction, then we put like this, and then find out what is the angle between them. So this is the basically angle between them, not this one. This is not the angle between this one. This is basically angle which we want to calculate, angle between any two vectors. So for finding an angle between any two vectors, we first concluded that whether its tail or tail parts joined together or not. If not, then first make it and then find the angle between them. That's simple. And we concluded last part of this unit, kinds of vector. There are different kinds of vector. First we started unit vector. If any vector of any magnitude, let's suppose this is a vector b, change our notation b. So unit vector is a vector which is in the direction of same vector but its magnitude is just 1. Unit vector. Unit vector is what? Vector which is in direction of unit vector is that vector which is in direction of same direction of given vector but their magnitude should be 1. Their magnitude should be 1. So let's suppose b vector. If b vector can be denoted by its magnitude and its direction, which is it is for magnitude, it is for direction. This is called cap also. So if we wish to calculate the unit vector in the direction of given vector, then first you do divided its magnitude. If you want to make any things, suppose like 10, if you wish to calculate make its 1, then divided by its own magnitude which is equal to 10, then we calculate 1. Similarly, if any vector can if you want to calculate unit vector in the direction of a given vector, then divided this vector by their own magnitude. So this become, which is also called cap. This is a vector which is in the same direction of unit vector, which is in the same direction of an unit, which is same direction of a b and whose magnitude is 1. Simply unit vector, equal vector, equal vector. In a scalar quantity, equal means if 5 equal to 5 means 5 is equal to 5. Any quantity is equal, its magnitude equal. But in the vector quantity, there is two possibility if its magnitude is equal, whether it is in parallel direction, whether it is in anti-parallel direction. So equal vector are those vector, suppose vector A and vector B. Just imagine vector A is like this, vector A and vector B. If vector A and vector B in the same direction of its heads part and its tail parts, then it should be equal. But if this vector is opposite direction, this is not equal. Whether it is magnitude equal, but its direction is not equal, so it is not a unit vector. Our next one is parallel vector. If any vector, suppose a vector C and vector D, whether it's what's magnitude doesn't matter. What's only matter is that whether its direction is in same or not. If any vector is called parallel, then their direction should be same. This is parallel vector. It doesn't matter what's the magnitude of both the vector has. Clearly, anti-parallel vector. Anti-parallel vector. Vectors which is in opposite direction. Similarly, this one. It doesn't matter what the magnitude has. Simply negative vector. If vector A, just imagine 5 unit and in direction like this. If another vector which is equal to 5 unit and just opposite to vector A, then it's called a negative vector. Just B which is equal to -5. This suppose it is in I cap. I cap simply in x direction, then it's called I cap. Minus 5 I cap. Simply negative vector. Third one, last one, congruent vector. Concurrent vector. Concurrent vector. If two two or more vectors are congruent, if their heads means its originating point are same, whether it's from this, like it's whenever the vectors origin point is same, then it is congruent. Coplanar vector. Coplanar vector. Vectors which is in lies in the same plane. Just imagine this is a phase, and vectors which lies in like this one, this one, this one. Whenever the vectors, like, just imagine this is the plane and vector lie in this, then it's called coplanar vector. Vector which is lying in the same plane is called coplanar vector. Orthogonal vector. Orthogonal vector. If two vectors are said to be orthogonal, if two vectors are said to be orthogonal, if the angle between we clearly clarify that just angle between these are 90 degrees. Clearly clarify that previously the angle, if you want to calculate the angle between any two vectors, then first their heads should be originating points of heads of both are same. Means this one origination, their originating point must be same. Orthogonal vector. And what is, and last one, if we multiplication of vector, multiplication of vector by scalar number, I call it scalar quantity. Just imagine the vector A, if it divided by lambda time of some time, then their direction will be same, but their magnitude increases by that lambda time. Suppose vector A is 5 I cap and lambda is 2 unit. If you multiply, then the b vector solution, then the b vector will be lambda time of A. If A is 5 I cap and lambda is 2, then another b vector which is formed, which is equal to 2 into 5 time of I, which is equal to 10 I cap vector. The next vector which is in the same direction of I cap, but its magnitude increases by the 2 times. Simply, so in this lecture we cover all the topics: vector, scalar quantity, vector notation, graphical representation, how to calculate any angle between two vectors. First, their originating point must be same. Unit vector in the direction of same vector, what is the magnitude is 1. Equal vector, what is equal vector? If two vectors are equal, then their magnitude and direction must be same. Parallel vector there, when its magnitude doesn't matter, but it's lie same direction. Anti-parallel lies opposite direction. Negative vector to same vector, same magnitude, but in direction opposite to the given vector is called negative vector. Concurrent vector, when the original point of the same for different vectors, called the origin vector. Let's suppose A, B, C, D, whatever you want. Coplanar vector, when vectors lies in the same plane, that is called coplanar vector. Orthogonal vector, when the two vectors are said to be orthogonal when the direction, when the angle between the two vectors must be 90 degree. In next video we calculate how we study scalar dot product, cross product. So we'll clarify both multiplication by vectors by any scalar numbers lambda time, which is increased by lambda times. So thank you very much for watching my video. That's all in this video.